evening, everybody. It's Friday night, my friends, and I'm back. We're going to be jumping back into some coding here, as we have a tendency to do on the Fridays. But welcome on in, everybody. Welcome, welcome, welcome. I hope everyone is doing well. Hope you're all healthy and happy and all those things. Kicking butt, taking names, getting things done, and enjoying life along the way. I gotta figure out where we left off, because I remember not leaving myself notes, which is a big oof on my part, but you know, that's par for the course here. I don't think I left myself a note, did I? Maybe I did. Start with image source record under the indicator. Maybe I did. Maybe I did myself a solid. Perhaps that has happened. EK directory image source. Okay. Yeah, because I guess we did. Yeah, that's right. We did the features and stuff under device here. So we can go into image source, which is a brand new record here. Alright, so we'll get that, pull that up. If I haven't already done it, I don't know. Oh, I think I've already done it. Okay, I already did that. So that's done. Image view is the next one. Here. Alright, so what has changed with that? They've added depth image. And is depth image. Okay, so they just added a property for making a depth image here. Boolean depth image, which I have added already. So that's good. So we're done there. And then pipeline. We need to add the descriptor sets layouts. Where is this at? This is under... in the constructor, and it's under push constant range. All right. Line chapter 8 here. So where are we at? Here's a push constant range. All right, and then we got base descriptor layouts. Okay, so push constant ranges, and then so that creates create pipeline layouts. I think this is all in here. So wait a second. Color blend attachment state. There's the push constant range. So I think that'll go in here. Oh, there's the crate info. Okay. So does this doesn't rely on anything else, right? Does this rely on anything else? Push constant range. It doesn't look like it. Okay. Build info. Push constant. So we got pipeline build info coming in. Already have there. Okay, so I should be able to just put this in here. It looks like. Yeah, so VK push constant range buffer. What's wrong with this? Already defined in the scope? Oh, wait. Oh, that's not what I'm trying to do. I'm like, yeah, it is already there. It's descriptor set layouts. Tools. Info. Set layouts, okay. Do I not? Pipeline build info. That's the next one on the list here. Descriptor set layouts. Okay. So we go in here. Add set layouts. So we got a setter on it. And getter, and that's it, right? Setter and getter. Alright, so just add that to here. Lists. Set layouts. Set layouts. Okay. We're good there. So then I just go back to here. Just info, get info that descriptor set layouts there. Cool. That's not null. Then it's not size, else 0. Buffer. Stack malloc long. For layouts. Okay, so is there a layout buff that puts I guess there's no okay, there's no put without an index. I mean, you can put a whole. Well, you can put. Yeah, no, you can put a long in there without the index. So, yeah. So all we really need here is. I do need to know the number of layouts in order to in order to do that. So layout buffer put, and then I just need a long array, right? So I can just say scripter set layouts stream collect what is it scripter set layouts get ID no, you know what? It's map to long. Right, and then dot to array. Boom. Okay. That'll work. So that goes in there, and then where is this used at? Well, that's piped into the pipeline layout create info, which I think I have in here, right? Yeah, pipeline layout create info. Okay, that works out well. P set layouts, layout buffer. Okay. Is that the only changes? Yep, that's the only changes. Okay. And then we're gonna go to swap chain there. Okay, so swap chain, so where do we start here? Create image views. That's it, just the one thing in create image views. Okay. That's probably the one that's flagged here, right? Yep. This is in build image views. Alright, and then just passing false to it. view data, and then false. Yeah. Yeah. Go. All right, cool. That's an easy one. All right, now we're getting into the Big Bertha things. Okay, texture. Wait, didn't I do texture sampler, and texture sampler info? Or did I not do them yet? That's a good question, because I don't remember here. Oops, that's not what? Have Vulkan texture. Yeah, I did this because because I didn't want it to get confused with the regular texture class. So I have VK staging buffer. Yeah, I think so. I have that. I have texture there, and then texture sampler. I mean, this is good that I'm retrying them again, just to make sure that I haven't missed anything. Okay, I haven't done texture sampler yet. Okay. So that's what we're gonna pick up here. Vulkan texture there. Okay, so model, new Java class, texture sampler. Will do. Cool. Get this started. Just a tiny bit. Kind of loud in my ear here. Private static final int next and CO trophy 16. Okay, and then private final along ID, I'm guessing. Oh, should I call it Vulkan texture sampler just to keep with the yeah, maybe. Yeah, we'll do that just to keep with the naming convention that I have right now. Okay, I'll assume this is logical device. Texture. What the hell is in texture sampler info? Is it worth having a whole thing here? I'm gonna say no. This the two usages. What's it being used for? Texture sampler info. Wait, chapter 8. There are different chapters here, but oh no. I'm just gonna pass these in for now. If we need another thing, then we'll get another thing. This is just kind of silly after a while. That way. Just do it that way so it's not this level of silliness. Sampler create info. Alright. We'll do that here. Info, okay, sampler, create info. Magnification filter, VK13, VK filter, nearest. There you go. Very good. Filter. Address mode U. UV and W. Okay, so they're all address mode. Go. Border color is border color. Unnormalized coordinates. It's false. Here and navel. False. Compare up. Okay, 13. Okay, compare up. Never. Go. Map mode. Sampler bitmap mode nearest. Minimum level of detail is 0. And max level of detail is MIP levels. MIP level detail bias is 0. Oops. All right. And that's it there. And then if Okay, so if anisotropy and device is sampler anisotropy, then info anisotropy enable is true, and max anisotropy is set to max. There. Okay. All right, and then we're just doing long buffer. Long one and oops. Okay. And then Vulcan tills fail if needed. VK13 VK create sampler. Device. Get device. Info. No. Buffer. L2 8 sampler. And then list.d equals buffer get 0. Okay. So we're there. Alright, and then we just have a cleanup. It's just 13 VK destroy sampler. Device, get device. ID, and then null. Alright, and then we just have a getter for the ID. Alright, sweet. That was a relatively straightforward one. So we don't need the info, and then this is, they're adding the descriptor allocator to their giant nonsense class that they pass around everywhere. So let me see. Descriptor allocator. Yeah, we'll just have to see where I'm going to put that. That's all there is to that. So there is, in the utilities, there's a copy matrix to buffer. Here it is. Copy matrix to buffer. That's new, right? Copy matrix enough to buffer and create host visible buffer are two new things. So I should probably do those. I guess I'll put them up top. Might as well. Might as well. Static void copy matrix to buffer device Vulcan buffer matrix 4F matrix and the offset. All right, mapped memory. What are they doing with that? Mapped memory is going into there. Alright, so buffer map. Light buffer. Till then byte buffer. Map to memory. Hints. Buffer. Requested size. Just get offset into the buffer. And then I should name this something else though. There we go. Just so it doesn't get confused with the other one. Okay. So we have that and create host visible buffer. Static. Vulkan buffer. Device long size int usage ID just set layouts okay. Buffer device size usage VK13 VK memory property hosts visible bit board width. Okay, memory property hosts parent bit. All right. And device, so descriptor set oh, this is where they're doing that. They're grabbing a descriptor allocator. So we're gonna pass the descriptor allocator in. Equals allocator at descriptor set device ID layout. All right. Set buffer device buffer get requested size layout get layout info binding and then layout get layout info descriptor type return buffer. Okay, that's all the changes they made there. All right, then under model here, so material data, mesh data, And mesh data, model binary data. Data model generator. Try to figure out where to start here, because some of these other data things I probably won't want. Model generator. Okay, this is the main. Okay, this is where they're generating the files from a model object. Okay. Yeah, we'll start here and figure out where we're going to go from there. Because the model loader looks like it just reads the JSON. So that won't be too bad. Yeah, model generator here. Because I'm going to generate. I'm going to do the generation the proper way. Or at least I'm going to try. We'll see. So model generator. Okay. Embed text ID. What the frig is that being used for? A regex pattern. It's looking for 0 or more instances of the numbers 0 through 9 with at least one number being in there in that match. Okay. Sure. What is that? What's that used for? It's the only usage. Embed text ID, match your texture path. Huh? AI texture path data string. Okay. Just trying to get the paths for. Huh. Just trying to figure out where to find the texture. Excuse me. Just trying to figure out where to find the texture, I guess. Embedded texture. Oh, it's trying to get the embedded texture IDs. Matcher matches. Group count is greater than 0. Parse int. Matcher group. Embedded texture index. If textures get embedded texture index. File name, data string plus PNG, directory, what is that doing? pulling the texture file out of the object and dumping it to a different path, it looks like. That's what it looks like here. Yeah, because it's opening a file for read-write. And it's writing all the data out to it. So it's basically extracting the texture from the main file and then just dumping it into a PNG file. Okay. I mean, that's fine. Hey, Dumb Guy Codes, welcome on in. No, no game today. Friday nights and Saturday nights I try to do some coding. Some coding streams. Usually, unless I'm really not feeling it. But, yeah. But welcome on in. How you doing? What are they doing here? So, okay, so you're just pulling the textures out and putting them into making files out of them. Okay. Edit texture index. There's gotta be a better way to do that than a regex, I would think. I would think there's a better way to do this. Because the... Because this is this... this isn't in a loop, is it? Yeah, doesn't look like it's in a loop. I mean, I guess I should look further. Oh, it is in a loop. Okay. Well, I mean, that makes more sense. It was like, it's got to be in a loop, right? Because there could be multiple textures. Okay. Okay. So... Let me see... Huh. I mean, I guess that's the only way to do it. I feel like there's probably a better way to get this, but like you would think that it would have textures get. Huh. AI texture. I would think there'd be a better way of getting this. Well, we'll see when we get there, I guess. For now, it doesn't hurt to just follow along. Alright, so this is it's technically under model, but really it's I'm going to say new package. Version, we'll say. Under that. And I'm not going to call it model generator. I'm going to call it model converter. I think that's more what it is. Logger factory logger converter class. There we go. And private static final pattern. File. And we got star. 0 to 9. Hitting the wrong buttons. Go. One or more of those. And specifically looking for a slash. I wonder why it's looking for a slash and then star 0 through 9. Huh. Okay. Final. It's flags is this is where's this coming from? Okay. Just normals. AI process join equal vertices. Triangulates. Fixed and facing normals. Calculate tangent space. Transform vertices. Okay. And they're doing a main method, which I am not going to do. I mean, I can put a main method in here, but it's not really what how I'm gonna run it though. So I'm gonna kind of skip some of that. Do need to put a actual run method here, so. We'll just say process. Is there anything that this is doing? It's just doing a new model generator. Oh, which is just, it's just called, yeah. Yeah, it's doing that because, yeah. So, yeah, the main method isn't even necessary there. What we're going to do is say, need, I guess we're fine. Do I need, does this need to be, these are all private, right? So all these could just be, in theory, just static. Oh, well, there is a, no, model path is just a parameter. Hmm. Huh. I'm debating whether to, yeah, you know what, I'll leave it as a, I think what I'll do is I'll just do a static get instance here. What's the problem here? Instantiation of utility class model inverter. Yeah. I don't know what problem it's having. I guess it's just trying to warn me about it, I guess. I can keep a I don't need to. I don't need this to be just a. Yeah, I don't really have a need for it to be a single instance, right? Like I could fire up as many instances as I wanted to on multiple threads and convert a bunch of things. I guess in theory, although it really depends on if this is laid out that way, because it looks like model path. Oh, model path is passed in. You know what? Screw it. do model path doesn't even need to be a thing, it can just be passed in. Yeah, this is, yeah, I'll just do a public void process file. Right. And then that's, yeah. Doesn't have to be any more complicated than that. Just do a new model converter dot process file. Whoop, done. Right. And honestly, is there any benefit to me even having it be an object and not just make it static? Let's do that, and then just make this a proper utility class that you can't instantiate. Sure. No, honestly, I think what I'd want to do is probably pass like an array of model files in, or like a directory or something. Like instead of, well, maybe I'll have like a process directory or something like that, and have it like spin itself off and do multiple files simultaneously, probably. But that's for tomorrow me, or a future me to worry about. All right, so. All right. All right. Is there a no, okay. Just making sure. That helps to have the right thing here. File. Is this? Oh, and bring in AI scene. Import file. Wait. Oh, it just for crying out loud. So they're putting it into a file just to check that it exists. What does this do? Let me see. Model file flags. What does this return? If the call succeeds, let's return AIC structure. We stable until recent import is called. If the import fails, null is returned instead. Call get error string retrieve human readable error text. Okay. So surely there's a better way to just do this, right? Without building up a thing that exists. What does that take? Oh, it takes a path. All right. So our file exists. Yeah. You know, it's weird. Oh, this is, what am I doing? This is throw a new runtime exception. Exists. No. Good. All right, it's a little bit better. If scene is null, throw runtime exception. Error loading model. Is that S? Okay. File ID. File ID contains next index. What the frig? Oh, they are using model file again, but why? So getting the name. Of the file, if it contains a period, get the substring. Oh, they're trying to get the name of the file without the extension. Okay, I think I know why they're doing that. They're trying to get the name of the file without the extension, so that they can name all the other files that they're going to write after the same name, but I'm wondering if that's even worth it. I guess technically for early on here, it's probably worth it. I would say. Let's think. I just hate to create a whole file thing just to get the name of the file. I wonder if I do the path here. File name. Turns the name of the file or directory denoted by this path as a path object. File name is the farthest element from the root in the directory hierarchy. Okay. Yeah, so that's we'll just do that. Alright. So, let's see. Name. File name returns a path. Oh. Was resolve. Name. I wonder what that does. Range from 0 to max. Returns the name element of this path as a path object. Let's count -1. I don't think that's what I want to get. Two file, get canonical path. I guess I'd have to do 2-file get name, which is kind of weird. It's weird. I have to go back up to make a file. And then go grab the name. That's just... that's just... Alright, that's not worth it. That's not worth it. Alright, fine. You win. File... So let's see if there's anything else on here. Get... It's just get name is all we got. Okay. Okay. I wonder if there's a that would be pretty funny if there was a string utils. Move ends. Move ends. String to remove. That's no. So move ends. Let's see. I wonder though. Name utils. Apache Commons IO. Name utils. Get base name. Bet that does it. Gets the base name minus the full path and extension from a full file name. This method will handle a path in either Unix or Windows format the text after the last forward or backslash and before the last period is returned. Text after the last forward or backslash and before the last period is returned. That's fantastic. I can just give it the string of the name too. And then there was something else I saw in there too. File. Name utils. Okay, no. Thought I saw exists or something on here. So wait, but where did file name utils come from? Note, you may be able to avoid using this class entirely simply by using JDK file objects in the two-argument constructor file string. Most methods in this class are designed to work with both Unix and Windows. Okay, most methods recognize both separators and both sets of prefixes. This is still okay. That's still a thing. All right, that's fine. Then I don't need to keep this file object around then, right? Because they use it for anything else. They use it for get parent file. I guess, okay, they're getting the parent directory in order to know where to put the files, I guess. Okay. Fine. So keep that around, but I'm just gonna do this. So string model ID. Right, and then what does this take? File name. There we go. Okay, that works. Oh, jeez Louise. Oh. The cold weather has finally gotten to my skin, and I've got like little cuts on my like thumb and my knuckles and stuff. And I move a certain way, and it's all like having a bad paper cut. Well, it's from the cold. Oh. Let's see. Oh, excuse me. Excuse me. You know what? I need to stand up and stretch for a little bit. I know I haven't been. Maybe we've gone almost 90 minutes, but not quite. But I do need to stand up and stretch for a moment. So I'm going to do that. So hang tight, everybody. I'll be back in a few moments. And enjoy the music, please. Okay, I am back. Nice walkabout and a stretch here. That's good. Okay. Now then, let's see what we got going on here. Is that working? Just see something real fast. It appears to be. Okay. I wasn't sure there. Anyway. Ow, that hurts. I got some stuff I can put on that. It's just bothering me right now. It's the cut's like right on my thumb, so as I'm moving around, it's It's stinging a bit. All right, model bin data. Model path. This is one that they created, right? Yeah. So what does this have? Index file path, index output, vertex file path, vertex output, index offset, vertex offset. Okay. So right, so this is the JSON file that I saw them writing. And I didn't understand why they bothered to write, I mean, I know why they bothered to write a JSON file, but I don't know why they bothered to separate out the indexes, because they're doing them as data output streams. For some reason, and this is what I don't understand why they're doing that. Because at the end of the day, it's going to become an integer. Or a long for us. So it's like, why not just read them in and put them out as longs or integers? So let me see what they're doing here. So number of materials. Model file, parent file, create materials, get I, process material, material data, right, and then meshes, number of meshes, process the meshes. The model data, what? Well, oh, I see. Model bin data, model binary data versus model data. Okay. So write a JSON file. Field naming policy, lowercase with underscores. That's terrible. Generate model file. Materials. That's just a string. That's a string. So what is the... Wait, what is the generate model file? Material file, substring file writer, material file, material lists. Oh, it's writing the entire... No, it's converting the lists. Yeah. It's converting the list. So that's this one. It's process material. So what's coming back from this? Material data, material. So it's just... It's bringing that back. Diffuse color. Okay. Mesh data. Again, it's just writing strings and ints. So why is that? Why did I see those as binary files? Process mesh, model bin data. vertex output. Okay. It's just writing, yeah, it's just writing floats to, for crying out loud. What a goober. Seriously. The person that wrote this is just a goober. It really is. It's just like, why just build up later on you're building, just put all these are floats, right? Yeah. So just put all these into either an array of floats, since this guy likes arrays, or a list, and print the damn list or the array out. You don't need to like write it out in binary. Like, what the frick is wrong with you? You just make it harder to parse later on. It doesn't need, and then spoilers, it doesn't need a separate file. Then you just toss it all into one file. The only separate file you need is the texture file, because that's a PNG. Okay, so suffice to say, I ain't doing that crap, because that's just silly. That's like a whole other level of just silly. So I do need a object to encompass them all. So I'm gonna say conversion. We're gonna say new Java class. We'll do I guess I'll just call it converted model right now. And then what do we have in here? So we've got I don't need the various file paths because we're just going to have one file. So I'm just going to say, yeah, I don't even need to say anything there. Index offset, vertex offset. It's index offset and vertex offset. Increment index offset? Increment vertex offset? Okay. Okay, I guess I'll put those in there. Private int index offset vertex offset, and then I think we need what do I want to put there? Vulkan model and Vulkan material. What's this material? So I'm guessing private list Vulkan material. That'll probably be part of it. Sure. That'll be part of it. And then I guess Vulcan Mesh, private lists, Vulcan Mesh, meshes. Do I have anything else inside Vulcan Mesh? Oh no, Vulcan buffer, number of indices, material. No, that's not it. Vertices, indices. No, it's gonna be Vulcan. I guess model. That has meshes in it. So no, it's not going to be, well, yes and no. Because this has got the versus texture coordinates. Alright, well I will need something to hold those because this is all janked up here. Indices versus indices. Vertex buffers, index buffers. You know what? Okay, so this is one of the few times when I'm going to say that their objects that they've been passing around are actually useful. So for this one, I'm going to do new, and I'm going to do Java class. We're going to do a record. And we're going to say Vulcan mesh data. Is that going to work with a record? Or should I make it a regular? No, I'm going to have to make it a regular Pojo. because I want to use. I think Jackson will now work with records. I think, but just for the sake of argument, let's make it a regular Pojo. And then I'm going to come over here. Grab those. Okay. No. All right, good. So it's Vulkan mesh data. So what I'm going to do is put an override on this. Well, I gotta change it anyway, right? So let's just put Vulkan mesh data here. No? On here. The final arguments were found 4. Huh? Was this an existing error? No. What? What are you talking about? Vulkan mesh. 1, 2, 3, 4, 5. 1, 2, 3. Oh, this had to be broken before, right? Material ID. Huh? Wait a minute. Oh, material ID. Was that just added to? I think that was added. What do they do here? They don't have they don't have anything in there. Wait, was that the right Vulcan model? Yeah, chapter 8. Huh. See the material ID. So I guess in Vulcan mesh data here, I'll just put private string material ID. Maybe. Just pass it that way, I guess. All right. There we go. So then I can put Vulcan mesh data now in here. What else? Process mesh. Indices. Add position to mesh ID to ensure unique IDs. Oh, for the material ID. Okay. And then texture. I guess we just need the texture path here. Alright, so I know where to find it. Yeah, that seems reasonable. Alright, so getter and setter on all those. For sake of argument, we'll throw a 2-string on it. Okay. Mesh, index buffers model. There you go. Back here again. All right, all that to just get us to the point where we can say converted model. New converted model. Okay. Order of materials. Number of materials. Good. 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 Okay. And material data. Material list, add material. Let me think here. What do we have in here again? The list of Vulcan materials and Vulcan mesh data. Okay. Alright, so lists material materials is new array lists. I'm not going to worry about parent directory yet. I don't think I need to worry about that. So I'm just going to do for A0, I is less than number of materials, I plus plus. And create scene. Get I. What's it doing with the AI material? Oh, I see. Okay. Ready texture path, diffuse color. Which I think I have in here. Yes, ID texture path, use color. Yes. Can I set those? ID texture path, diffuse color. Yes, I can. Okay. Cool. So material. Sorry, I'm ahead of myself here. Okay, so create that. So then we want first materials and I need to do the process material here. Private Vulkan material process material scene AI material model ID and index. So then process material. Yeah, I don't know what it needs with the base directory. What are you doing there? Oh, because they're processing the texture along here. Okay, so that's why I need the base directory of the thing. So string do that texture directory. Throws IO exception, yeah. That makes sense. Vector 4F. And color 4D color 4D that creates result is material color material that key color diffuse texture type none 0 color if result is success, then diffuse vector set color.r, color.g, color.b, color.alpha, right? Yep. All right. Diffuse texture. Is that a string? Because it's the texture path. Okay. Okay. Scene material. Texture directory. Texture type diffuse. Okay. And then return new material. Where the hell did model name come from? Okay. Model ID, right. Model ID plus, oh, screw it, just do percent %s material percent %d, and it's model ID and then index. What's the next thing? Diffuse texture path. And then use vector. She's got, okay. Yep, it does that. Let's do process texture here, which I think is up the top of the file. Let's process texture coordinates. Here's process texture. So private string process texture. Material. String, texture directory and texture type. Okay. Back push. More embedded. Textures is scene dot m number of textures. Where do they use that? Okay, so that's processing them. All right. string texture path is AI string collect the stack there. Okay, material texture. Material texture type 0. Texture path. Hit buffer. No. No. There we go. Okay. So read that in. Said our texture path is texture path data string. What are we doing here? So edit texture. So try and get the texture path. Alright. I guess we'll just go with this for now. I don't know if this is all that necessary, but wait, this is just a string, right? Oh, if string utils is not blank, solve that. Matcher. ID matcher texture path. Texture index equals matcher matches and matcher group count is greater than 0, and it's integer parse int matcher group 1, else it's -1. So if embedded texture index greater than equal to 0 and it's less than the number of embedded textures, texture texture creates scene and textures. And textures get texture index. What are they doing here? Base file name is the data string plus PNG. Okay. And base directory plus slash plus base file name. Okay. All right. I'm just looking at it. I was just looking at it to see if there's anything that I could, if there's anything I should maybe change, but I think we're just going to go with what's here. Path equals s/%s texture directory base file name. Logger info bring texture file to texture path. Channel open texture path not texture directory. Open option that create right Okay. Is right over right? That's just right access. Create new file if it does not exist. This option is ignored if create new option is also set. Check for the existence of the file and the creation of this file. Okay. Alright. Sure. What's wrong here? IO exception. Didn't I put IO exception in? Oh, I didn't. Channel right. Data compressed. Okay. What else? Texture path equals %s %s. So texture directory and then file utils. I had something here. Get her temp directory is file newer. Read lines, stream files, file array. Didn't I just see there was like a get am I losing my marbles here? Didn't I see a file name utils? That's what it is. File name utils. Get name for texture path. Not texture path, texture directory. Wait. They have it wrong here. They meant oh no, they're correct. There's texture path there set before the if. Okay. That's right. Texture I call it texture path? I did. Okay, texture path. Alright. That's fine. That's fine. And otherwise, return texture path. I think that's I think that's correct. Let's process texture, process material. So then back up to process file here. We're calling process. Can I make these static? I guess I can. Process material, scene, material. Oops. Model ID. Texture directory would be file get parent file. For a second. Handle exception, Java IO exception. Did they throw? They do. Okay, so file exists. I have the file. So I can just say, here I can just say file. Just have to get path there. Data by now required, that's fine. Okay. So then the meshes here. Meshes. Doing ascene M meshes pointer buffer. Okay. So what else do we have here? Scene. M meshes, because it does bring back a pointer buffer. Oh, which we just create. Okay. Alright, so we have that. So pulling those meshes in, and then we're doing lists of Vulkan mesh data. Mesh data lists. Array lists. I is less than number of meshes. I plus plus. Okay. So then we're building a AI mesh. Mesh that creates get I from that. Okay. Okay. Right, so mesh data list add process mesh material list. I guess yeah. Okay. So parsed materials. I don't know why it wants me to pass in that, so we'll just hold the thought on that right there. I guess, well, converted current model. I guess I can pass it in there. I don't know. To do with it. But let's go make the process mesh. Method here. And we want mesh list Vulkan mesh data. Oh, wait, no, that's Vulkan material. position and model. Okay. What are we doing here? Vertices, collections, and copies. Oh, if texture coordinates is empty. It's making copies of 0. Okay, so we have, let's do a list, float, vertices, list, float, texture, words, and list, integer, indices. Okay, let's get back to the rest of those in a minute. Process of vertices. Mesh, mesh. Right, and then list. Oh, I forgot to look static. List float. Yeah. List, vector 3D, buffer, equals mesh, vertices. Should be able to just do var here, right? Yeah. While vertices has remaining. AI versus the get versus that add x and then Turn that. Okay, and then process texture coordinates. Process texture coordinates. List. Okay, and then var texture. Texture coordinates 0. Well, no. And AI texture coordinates remaining, else 0. Zero I is less than the texture coordinates I plus plus. Alright, and then add coordinate.x and 1 minus .y. Alright, and then turn texture coordinates. Okay, and indices. Good. Lists. Sure. C is equals lists. That very good. And what do we got? Your faces. Faces. Mesh dot m faces. Int I is 0, I is less than number of faces, I plus plus. Okay. Oops, buffer. vertices. And then auto buffer as remaining. Vertices.add. Forget. Return that. Okay. So we have those. Vertex size. Okay. Alright, so int vertex list size is vertex size if texture coordinates is empty. Texture coordinates equals collections dot n copies. So list size divided by 3 times 2. 0. Okay. Vertex output. Get vertex output. Vertex size. Blah blah blah. I don't need to do any of that at all. None of it at all, because I'm just going to write it out as is and read it back in as is. Yeah, because they're writing them out. Vertices, 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 and then texture coordinates, which we don't need to do because we end up doing that anyway when we read them back in. So this is, even if, yeah, whatever. I mean, I get that they're doing it because that's, you know, they're writing both to one file, but again, the whole thing is silly. Same with the indices output. Add position to mesh ID to ensure unique IDs. Oh, positions what's passed in. Okay. Oh, that's why they were passing this in, so I don't need that. Because they were creating out the mesh data from there. Yeah, vertex offset. don't think I need either of those because I think that's going to be used for reading them in, is my guess, and I don't need to do that because I'm writing them correctly in the first place. So, yes, I don't need those. What am I doing here? So what am I skipping? I'm skipping pretty much all of that, I guess I'm adding the mesh name to the material. For the material ID, or the mesh position for the material ID. Okay, so really just building up the Vulkan mesh data here. So let's do this first. String material ID, or I guess mesh ID. Equals %s underscore %s. Be mesh and name data string and position. Material index, material list get. Material list get material index ID, material ID. All right, well, let's do return new mesh data. What do I need here? Oh, I made this a regular project. Set indices, set material ID, set texture coordinates. Really, I should just do this at the top here. And really just do that. Stream net to long. No. Stream to array. No. How the hell do I do this now? There's a 2 right. Let's do vertices to array new floats. Yeah, you know what? Array utils. Primitive. Do to array. That's just the best way to do it. I don't think I could do... No. 'Cause that doesn't make any sense. But will this, I think it might auto box if I do floats. No. Yeah, no, it won't auto box it down to a primitive when it's an array. Oops. That size. problem now. Okay. Because it's going to a primitive. There you go. It's ugly as hell, but it'll work. What's the it's just telling me I have it misspelled. Yeah. Okay. So vertices, texture coordinates, and indices are all going to be the same, right? So texture coordinates to array. Right, and then sets the change to change to that. Okay, that's makes everything a little bit nicer to deal with, maybe. Of course, I put the wrong thing on the wrong thing here. Vertices. Texture coordinates. Indices. There we go. Text list size will be turn data to get versus the length. So I guess there's a array utils is empty. this will be in copies. I wonder if I could do an array thing here. Array tools. Set all. Yeah. It'd be easier to just do it the way it has it here and then just say to array new primitive there on that. Okay, and then we could say, so we got mesh data. Set material ID. Material ID is material list, material index, material ID. Okay, I don't think I need the material ID, just need the mesh data ID. So it's that. So this is really not material ID, this is mesh ID, right? Is it the material ID? So Vulkan Mesh takes material ID. Okay, so it is the material ID. Really confused on now, so because they got two IDs that they're throwing in here. They got the mesh internal name and then the material ID that they've pulled from the material lists. Material index. There's no. They're just copying the material ID over. From what was passed in. which is just that. Oof. Sure. Oof. Excuse me. Has ID ever used Vulkan Mesh Data ID? Used to found in project files. So it's never referred to, it's just there. It's never used. Which is what I was kind of figuring here. Alright. Yes, let's just get rid of that for a second here. Let's do int material index is mesh and material index. Material ID. If material index is greater than or equal to 0 and material index is less than material list dot size, then set material ID equal to material lists dot get material index ID material ID there. All right, done that, and yeah, we don't need the other things for the way that we're doing things. So back up here. So I don't need to pass the converted model in. Alright, and then there's, what are we doing next? Model data. And then they're writing it out. Okay. Okay, so that's really the last part of this is just write the file. All right, I'm gonna have to stop there though, because my brain is pretty much stopping here. So we're on model converter. Okay. Yeah, I'm not gonna commit anything. I'm just gonna keep it to save for right now. Actually, you know what? Just in case, let's go and commit it. It's not hurting anything. I'm on a branch anyway. And even if I was on a branch, it's not hurting anything. Yes. Okay. That's all committed. Alright, good. Good. That's all out there. Anyway, my friends, that's going to do it for me for tonight because I am tired. But it looks to me like, I mean, we're at the point where we're writing out, we're converting model files over, which is something I can kind of test without launching the whole shebang, pretty much. So we can probably tomorrow we'll finish out that file and then try to maybe write a JUnit test or something to just to fire that portion up and have it read in a file and write out the JSON for it and write out the texture for it. Like I'll read in the actual book chapters file and see if it generates what I'm expecting. So that's one nice thing about that is we can kind of test that in isolation without running the whole thing or needing the whole thing to be running. Although it's probably going to stop me because it's not going to compile with all the errors in there. So we are going to have to at least go through and fix any outstanding errors I have. So there's that. But there may not be all that much left as far as files we have to finish for the chapter. So maybe we'll just get all the files done and then I can do that test maybe. We'll see. Anyway, friends, that's it for me for tonight. If you happen to run across this on the YouTubes and you have a like and or a subscribe that you can spare and maybe toss my way, that would be tremendously awesome and great, and I appreciate it greatly. It helps out tremendously. Otherwise, thank you so much for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. I hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
This is the way.